Hello everyone, this is Amit Lathikara. In this video, I'm going to demonstrate how can we check whether number is prime or not using a Python program. So before I start, let's have a basic understanding of prime number first, that what is a prime number. Usually we are considering any number as prime number if it has only two factors and that are 1 and number itself. So this is the simple understanding of prime number. If number has only two factors, 1 and number itself, then number is prime, else number is not prime. In other words, if a given number is divisible by only 1 and number itself, then number is considered as a prime, else it is not prime. So for any number, if we are starting with 1, means if you can start dividing given number with 1, then 2, then 3, up to number. And if we find its divisor as 1 and number itself, not any other number, then number is prime, else number is not prime. And let's consider a practical example. Say I want to check with 5. So as per the earlier discussion, if you don't consider these two numbers, then if we start dividing given number with all the numbers starting with 2 up to the number minus 1. So 5 minus 1 meaning 4, because if we divide 5 with 5, of course, we find remainder 0. And the same way, if we divide it with 1, we'll find a remainder 0. So 5 is it divisible by 2? Not divisible by 3? No. Divisible by 4? No. Meaning it's not divisible by any numbers other than 1 and number itself. So 5 is considered as prime. Let's have another example. So 6. So in case of 6, let's start with 2, then 3, then 4, then 5. 6 is it divisible by 2? Yes, it is. 2 is a divisor of 6. One of its factor is 2. That's why division is possible. Remainder is 0. Meaning we found a factor other than 1 and 6, that is 2. No need to check. No need to check remaining numbers. Straight away we can conclude this is not prime. So there are several ways to check whether number is prime or not. But considering the sequence of this video, I'm demonstrating a very basic and fundamental way to check whether number is prime or not by dividing it with all the numbers starting with 2 to number minus 1. If we find any divisors in between, we will not continue with other numbers in this division process. And we can use the concept of a variable named as flag. Whatever the name you are interested to give to this variable, you are free to do so. So I'm considering flag as 0 as the initial value. If we find any divisor, for example, here 6 is divisible by 2. So as soon as we find a divisor, we'll change its value to 1. We'll not check subsequent numbers. And at end, we'll conclude whether number is prime or not based on the value of flag. If it is 0, meaning no change, then it is prime, else it is not prime. So let's draw its flowchart first. It begins with start symbol. Then we need to take an input from the user to check whether number is prime or not. So input number, initialization of set of variables. Here in this explanation, if you can check, something is repeat throughout the process, and it is division process. First 6 we are dividing with 2, then 3, then 4, then 5, and in any of the cases, if division is successful, we are not checking subsequent number. So here after dividing with 2, we'll come to the conclusion that number is not prime. Here we are dividing with all numbers as we are not finding any factors. and we are concluding that number is prime. So basically it is a repetition. So what we require is a loop, concept of loop. So we require iteration within the loop, and let's have our variable flag. Let's initialize it with 0, and for iteration I'm using capital N. Division will start with 2. So let's assign 2 to this number, and this is what beginning of the loop. We are checking condition, that is whether we are dividing a number with n. So is n less than 0, because we are starting with 2 up to the number minus 1. So n less than number. Two possibilities, one is true, one is false. So what if it is true? True meaning we need to check whether number is divisible by current iteration value or not. So is our given number, let's divide it with n using modulo to check the remainder value, is equal to 0. What if this is true? What if this is false? So what if it is true? And what if it is false? If it is false, we need to increase value of our iteration by once to check the next number, and we need to go to the loop portion again. So let's connect it here. So this is my loop. If it is true, what we are doing, we are changing the value of flag to 1. So flag becomes 1 here. And then finally, we need to check value of flag. So let's save condition is flag is equal to 0, as well as this comes here. So is flag 0? Again, two possibilities, true and false. What if it is true? Meaning we didn't find any divisors here. So in output, we need to give a message. So print or display number as a prime. If it is false, then number is not prime because we have changed it to 1. So here in output, print or display number is not prime. Number is not a prime number. And finally, end of my flowchart. So stop. So from both the places, stop. So this is a simple flowchart. Based on this flowchart, let's write a Python program. So we need to take an input from the user. So let's have number, typecasting. Let's take an input from the user, enter any number greater than or equivalent to 2, because 0 and 1 we are not considering for checking is a prime or not. So this is the input. We require one flag variable. So let's assign 0 to my flag variable. Let's take iteration through 4. So n in range, we need to start division with 2 up to number. Then we need to check if our number is divisible by current loop iteration value. If number modulo n is equal to 0. If this is true, we found a divisor, we need to change value of flag to 1. And then we no need to check remaining part of the loop. So break is a statement which is going to break this loop. And once this loop is over, we need to check value of flag. So if flag is equal to 0, so in this case, we need to display a message that number is prime. So number is a prime. This is what my message. And else, if it is changed from 0 to 1, that number is not a prime number. So here number is a prime number, and here it is not a prime number. So this is a simple Python program based on a flowchart. It's time to check its output. So let's execute it, enter any number. Let me enter 5. So 5 is a prime number. Let's enter 8. 8 is not a prime number. In first attempt itself, it is divisible by 2. Let's have 12. It is not a prime number. Let's have 17. 17 is a prime number. So this is a simple Python program to check whether number is prime or not. And this is its appropriate flowchart. We are checking with 2 up to the number -1. So here it is less than. In this flowchart, let's understand how it works. Consider value of number as user is entering here 5. So what is the value of flag? It is 0 initial value, n is 2. So here 2 less than number. So 2 less than 5, it is true. So we are checking its division part. So my number is 5 modulo 2 is equal to 0. No. So we are increase value of n to next possible number by adding 1. So here in this case it becomes 3. So n is 3. 3 less than 5. Again it is true. We are checking 5 modulo 3. False. Changing value of n to 4. So here it's 4 less than 5. Again true. 5 modulo 4, 0, false, changing value to 5, n becomes 5. 5 less than 5, false, it is equivalent to 5. So what is the value of flag? It is 0. So in output, number as a prime. Let's consider one more case. Instead of 5, let's check next number, say 8. So let's check the possibility here. What if it is 8? How this flowchart works? So input numbers and number is here 8. Flag is equal to 0. N is equal to 2. 2 less than 8. It is true. 8 divisible by 2. Yes. So true. So value of flag we are changing to 1. So now value of flag is 1. We are not going to the beginning of the loop again. So directly false or true based on the value of flag. Flag is equal to 0. It is 1 now. So false. So in false, number is not a prime number. So this is how this flowchart works. And this is a basic Python program to check whether number is prime or not. I hope you enjoyed this video. Thanks for watching this video. Have a good time ahead.